Hello everybody, it is Mike Levin on Wednesday, July 27th, 2022. And for my next trick, I'll take the first step in creating a pulse on one of these Linux containers under Windows 10, under Ubuntu 18.04. So that's the environment I'm on. When I open one of these things up, this is sort of my Linux host system, which, as a matter of fact, LSB release all happens to be Ubuntu 18.04, and it's running Lxd. So I have gone through the rigmarole of installing it, getting it working, but you can do Lxcls or the word list, either will have the same result, to show you you're running containers. And so I can step into that container and deny you the pleasure of seeing it get set up from scratch. So I have recently created a post. It's my most recent blog post. I'm going to show you me creating a container from scratch because I just made those instructions and it's fresh on my mind. And then we can get a systemd running a Linux daemon. That word, daemon. So somewhere along the line, system services for, I believe, Unix and Linux were called daemons. And now it's just the tradition, but they're services. Anyone who has stopped and started services under Windows knows that there's processes that are running as long as your computer's running. There's things out there that are doing different tasks, and that is a big part of controlling technology, controlling those daemons. So I don't want to make this the most boring thing in the world. I don't need a lot of what I'm talking about here as part of this creation of a new container, but this is the magic line here, Lxd Launch, and then you give it a name. So this is kind of like a before. There's only the one running, and I'm going to stop it just for the sake of it because I don't want any complicated networking context. So I go Lxc stop and then the name of the instance. And now if I were to Lxcls, you would see it is stopped. It no longer has an IP and all that stuff. So we are going to take that command that I just copied out of my blog post, Lxd Launch images, Ubuntu /18.04. And whereas that last instance was called Looking Last, oh, I'm on the spot now. I knew it was going in this direction. I should have thought ahead. We want another Alice or Dorothy world related name spin on it. So I've been using Ahz, A-A-H-Z, over on my Windows 11 machine a lot for similar type work for the Linux host OS. So I'm going to use it here. I don't want to confuse myself too much. It's going to be a different spelling. There's Wonderland, there's Oz. This is a friendly place. This is where we're trying to go. So I am going to use names of lands in Oz. Map of Oz. Not Ox. Map of Ox. Does it know what I mean? It almost did. There's a map of Oz. And each of these color-coded lands is a land of a different people. Oh, okay. There we go. That's what I'm trying to get. There's Munchkin country. There's Winky country, Quadling, and Gillikin. So Munchkin, M-U-N-C-H-K-I-N, of course. That's what I'm going to be using. Oh look, my animations are gone. Isn't that interesting? You get enough going on a system and even your animations go away. So it's going to be M-U-N-C-H-K-I, Munchkin Land? Munchkin Land? That's not appropriate anymore, is it? That's not politically correct. We can't use names of the lands of Oz. I can use other lands. Winky, that probably means something. Gillikin. I wouldn't be able to remember these. Quadling. I'll go with Quadling. Creating Quadling. All right, so now when I do LXC space LS, I'm getting these things into my fingers. I don't have it really natural yet. But you can see that I have now these two containers. My original one I started out with is stopped, which is fine. And then this new one I just created is running. Now it doesn't have very much on it, but we don't need very much on it to get this systemd project underway. We just need to, for example, get into it. So let's get into it. We want to get into the Ubuntu User, which is actually kind of an issue because you can have go in as root much more easily. So it's another one of these LXC commands, EXEC, because you're executing. Now you're going to be executing against one of these named containers, so Quadling. And then this double minus, or double hyphen if you prefer, or double dash if you prefer, I don't know. And then a space after that, that's your delimiter to say, hey, a command's about to come in. So sometimes people do bin sh to get to a terminal shell, to get to a bash shell. But that would get you in there as the root user. So I'm trying to get into the habit here of doing switch user --login space Ubuntu. Now this will be my first time logging into this brand new container as this Ubuntu user. Will it challenge me for a password? Oh, I got something wrong. Oh no, I didn't. I got it exactly right. Look at that. We are Ubuntu at Quadling. See? Bam, we're in. So one of the typical things you do at this point is sudo apt update to update the software repository, because this is a brand new cloned image, if you will. You know, people talk about Docker a lot with this kind of stuff, but I'm a fan of LXD. It gives you the whole operating system, not just this application spaced slice. Or application sliced space, if you prefer. So you can already see, by the way, having logged into the container, one of the first things I did is something that requires internet connectivity. If I did not have a net connection from this new container I just created, which I can kind of see because there's an IP assigned to it, then I wouldn't have been able to do that sudo apt update you just saw. And you can see all packages are up to date. I don't have to do any updates here. So it's perfectly fine at this point for us to, well, next thing, because we've been doing stuff. I guess there's a zoom level I want to stay at to keep that from wrapping. We want to confirm we're running systemd as our first process. So PS is process status, by the way. So you can type PS and see what's running, right? These are the things that are running. So it's not showing you everything that's running. There's actually hidden processes here. And one of the first things you learn when you're learning the PS command is that you can do PS-AUX. Now I'll walk them through one at a time and explain it the best I can. So PS-A just means all that are actually running. And there's nothing more running that this has access to show than this, so it's almost identical. Now the U, I believe, is show it how a Unix, terminal would show it, or a Unix PS command, what have you. And then X, I believe, means for all users. So the U expanded the number of columns. You see, the number of columns was just time and command. Now it's expanded it out to all these different commands. And under command, it's like this longer format. It's the word command instead of CMD. Anyway, X will expand rows. See how now there's additional rows here instead of just the additional columns. I suppose you could take out the U for PS-AX and have the fewer columns, but the more number of rows. But you get the idea here. This is the PS command. So I'm going to clear. And now I can zoom bigger. PS, there's some different options here. One of them is -O, which is for custom formatting. And then you can say com, give me just the com column. And I believe I can hit enter and it'll show a few things, just the command column for PS. See that? But now the magic thing is you can do it for just a particular process. And even though it's not shown here because of your user status or whatever, if you put com1, it's saying for process ID 1. In fact, I could take out this interior stuff and I could just do PS1, and then that would be the long form or longer form of what you see here. Now this is almost showing you whether or not systemd is running in a single command. Actually it is technically, but it's giving you 2 rows, which is not necessary. So the last step, and you have to do it in here as opposed to out here, there's some bit of order sensitivity with these arguments, but you can put in no headers. I believe it's 1D. And there it is, systemd. So you can confirm that you're running systemd as the task name in process ID 1. That's what you want. That's what you need for this trick we're about to do. Now, if you like, you could turn this into an alias. That's the kind of thing, you know, people do, so that you could just say, you know, sys or something. I don't want to create suggestions that would be namespace collisions. So just remember that, right? This is optional formatting. This is naming the column you want. COMM is a special keyword. You just have to know that. And that will give you a little slice out of, because you can see this is COMMAND, and it doesn't say systemd there. It says /sbin/init, right? So there's a little bit of mystery here of like full path issues and stuff. And columns, column names, I just happen to know that from researching this topic. So moving on. When you're on a system that has systemd, that we now know we can confirm with this command, you can cd into /etc, okay, and then you can ls. There's a lot of stuff in there, right? This is default. I just installed this container, so everything in here is stuff that just comes with. That is so annoying, having that redraw error there. I wonder if I can get rid of that somehow. It's gonna run through this whole friggin' video, isn't it? Let's do function F11 to allow this to happen. So maybe I can go like this, or right click on the desktop and get out of it. No. Could it be a taskbar? Right click, Python 3, IPY kernel. Oh, maybe that's in here. Yay! Screen redraw bug eliminated. Alright, so anyway, there's too much to look at in here. I just happen to know, as I paste in stuff accidentally, I just happen to know that there is a systemd directory there. Now you can go system asterisk and it'll not cd. Okay, well it cd'd me in there because there was only one. But what I was going for is you could ls system asterisk just to confirm for yourself the names of the directories that are here. And there's the system directory. See that? So that's the one we're going into first. So we cd into system. Oh. ls-la, so we can see what things are what types, directory types and stuff. And that also does all. And there's systemd there. And that is in fact the directory. So from etc, you can cd into systemd. Okay, so that first step down has the d in there. Now this next step you need to go doesn't have the d. And you can see there's some config files up here, and there's a few other locations here, system, but what we're interested in is system, cd system. Now I'm doing this for the first time in a long time on a container. I have to tell you, this is now 15 minutes into the video, but getting to the point where we're going to do some little thing, just some little thing, to assure ourselves that we have control of a Python program. And so we're just going to get a program to run and have some output of almost any sort that we can look at. It's not going to do much. It's going to exit. So it won't have a while loop in there. I'm just going to do this from scratch. I'm just going to code something up and make it, make a .py file into a Linux daemon. Right here in front of you. For my next trick, I'll be hand coding a .py file and making it a Linux daemon. But before we get to the .py file, I'll show you the files that are in here. You saw that I did an ls in here already. Make it easier to look at. Now, if I vim one of these service files, I don't know, syslog.service, you can see it's a tiny file. It looks like what .ini files used to look like when those were big. It's a simple sectioning off of things with square bracket headers with a series of key value pairs underneath. There's nothing special about making such a file. And in fact, in my blog post here, I was saying keep this file accessible because I talked about it in a previous video or a previous blog post. Boy, my performance is tanking, let me tell you. I'm going to have to get something slower on my system. Let's close some tabs. We don't need all these Chrome tabs. Which is taking us closer to where we want to be over here. Okay. That's the one we were just looking at, which was to set up a new container. Now this one here talks about our systemd adventures. I actually talk about a bunch of other things, but at some point I finally get around to going in and looking at one of these .service files in this location. And this is what it looks like. In fact, I'm going to do a refresh because I just edited that line. You saw it pop from one thing to another. I edited that because I had proofread that knowing that this file was coming up. Because I want to create a file called pulse.service, and I might change the paths of these things. But yeah, we can make something that does a heartbeat right now. I actually might not make it the heartbeat right away. I might just make it a single beat, just one beat. Boom, the .py file runs, and then I output something like the date, the output of the date command into a file. I'll echo the output of the date command into a file. So yeah, that's a very logical approach. So we really are mostly interested in this. That is what constitutes a file that's going to have a .service extension. in the location that we are in right here. We took a peek at one, but there's no reason I can't sudo vim pulse.service. I paste this. Now it's not going to make any real sense to this with all these default settings that I have here that I'm going to have to change, but I am going to save it to confirm my ability to save it. All right, so that's technically sitting there as a potentially enabled and systemctl. The big win in doing it this way is that you have systemctl start, you have systemctl stop. Oh, and you can have it restart every however many seconds. So I'm going to have that restart to every 15 seconds. So maybe I'll do an append there. So every time it starts, it'll do some sort of file write that I'll just write into a Python program here. And these are our paths. Now I am going through a program called screen, and I'm creating a screen name called heartbeat, and in that screen I am executing the following command. It may be good to follow that pattern to have good habits right from the beginning. What this is going to allow us to do is to watch this thing being executed. And it'll also exit right away, so it's maybe not so smart to do. I can just do a while loop and make it stay open forever. If I make it stay open forever, then I can just put that back to 5. Whoops. No reason to have it checking for restart so infrequently if we're going to do a while loop. All right, so think this through for a moment. Just make it real, make it real. We will go through the screen thing and set good habits from the beginning. We'll call that screen pulse. I am going to change the whole identity of this project. Oh, I misspelled it there, that's why. Okay, from heartbeat to pulse. I didn't misspell it, I just started to delete it and cursored away. Curses. Yeah, that's more what I'm looking for, right? There's no reason to mix the concept of heartbeat and pulse. You know, I'll choose one and stick to it. Now I'm tempted to do pulse/pulse and bring the file form, the conventional arrangement of folders in line with a published pip installable package, and then make this a pip installable package everyone can use. But that would be too far ahead, and I think it's okay to just start out with a new GitHub repo that I'll create called Pulse. All right, so let's put that file in location. This does happen to be the user that we're using here. So I can save and exit, and then make the fact that that service is sitting there ready to be used. So I could do, you know, I'm not going to do it yet, but I could do service pulse enable, or systemctl enable pulse. I think that's the other way. So there's some different APIs floating around here. This is the right one. Systemctl is what we want to be using because it's what really goes with systemd. And those other ones like service are wrappers from APIs of things that came long before. So anyway, we're 24 minutes into the video. Let's see if I can hit this thing home. We want to now change our location to ~/GitHub. And being a container that I just created, it's not really there yet. So I'll go cd ~/ls. Yeah, there's nothing there right now. That's interesting. Yeah. Nothing is really necessary. All these mapped drives that I've been using, none of that's necessary for this Heartbeat project. So this is a good starting point for you joining in. I should almost start a new video at this point. If the Google AIs are listening and you're creating sections, here's a new section. We are going to make dir GitHub, because I always do that in my home location. So now I have a GitHub folder. Now I can cd into GitHub, and I am going to make dir pulse. So now we have /github/pulse. I'm not in there yet, but I can go in there by going cd space pulse ls. Okay, nothing in there, of course. Now, the Vim I'm going to be using is going to be without my vimrc, right? So I'll be using a plain vanilla Vim without my vimrc and my customization. So you'll be watching me getting on by with that, because otherwise I'd have to git clone or whatever, move a file around, something to get my vimrc here. Not the hardest thing in the world, but let's do it as plain vanilla, so if you're reproducing this experience, you can do the same thing. Not relying on my vimrc, which has a lot of customizations which you might not like or whatever. Okay, so vim pulse.py, print hello world. I think we're about to discover we are without Python, so I will probably be walking us through getting Python on this thing. Python. See, I didn't think so, right? So this is now where a few of these steps that I have documented here on setting up LXD come into great use. There's not even git, right? So this first starts with git. Here's another example. Git not found. So I think I did a sudo apt update. You always want to do this before doing all these pulls. I'm pretty sure I did this in front of you, maybe even in this video recently. Yeah, I created the container in this video, so of course this is the same thing I did near the beginning of the video. Sudo apt update. It's always good to have it in your habits. Now it's already up to date, okay? But now we're ready to install stuff. Sudo apt install git. Yes, I would like to install git. Hey, I've got my wolf t-shirt on, and I've got my wolf mug. I guess I'm feeling wolf today. About time. We're the pack. Let's run with the pack. All right, while Git's installing, we just look ahead. We're going to be adding this software properties common. I should probably look that up to make sure I really know what that is, but it's one of the requirements so that we can add the dead snakes repository, and then we can install Python 3.10, and then we can install Python 3.10 venv, which is not part of the default install for some unknowable reason, and then we can create that virtual env, virtual environment. So much about what we're doing is virtual environments, ladies and gentlemen. Virtual environments is probably a better term than virtual machine, because virtual machine implies a lot these days about the, number of sheer moving parts that are incurred as overhead. Fragile pieces that might break, and expensive pieces that occupy resources and bloat out your memory usage. So Unix people have long been rooting, shifting where their in-memory operating system retrieves all its file-based resources from. You just change your root, and suddenly it's like you're running a new operating system for all parts that are not in memory. That's what I'm trying to say. Why is this taking so long? Could be that I have other things running on the network, perhaps. Even screen redraw is slow. There's an interesting YouTube video here. If it took that long to install Git, how long is it going to take to install all this other stuff? Boy, sorry to make you wait. You're all running this at like 1.75 or 2 times speed, I presume. That's an awful lot it's installing for Git. Did you ever have any idea how many requirements Git had? Git is a whole friggin' ecosystem, it seems. Lib Perl 5.26. So the ability to run Perl scripts, perhaps embedded, is part of the requirements for Git. Of course, cryptographic stuff, Perl modules. Fascinating. All right, so now we didn't have Git before, we do have Git now. We're going to get this next thing. It's probably bad practice, but while we're getting it, we'll figure out what it is. I ought not to make my system do anything more than it really has to, should I? But I'm installing something. Ask Ubuntu. Okay, fine. Am I risking demonetization every time I click into a website because of the ads it might be running? Probably. Abstraction of the used apt repositories. It facilitates the repositories that you install from common. Abstraction of the used apt. Independent software vendor sources. Well, anyway, it's asking me whether to continue. It was wasting all that time in the background. Sorry about that. But that was good. That gave me a chance to answer no if I didn't like what it was saying. Hope that car in the parking lot doesn't demonetize me. The boom, boom, boom of the bass of their song. At least it gives me something to talk about while I'm waiting for these common facilities. It facilitates. It's not facilities. It's... Okay, so anyway. I'm asking my feeble little system to do too much, I believe. There's a lot of Python 3 stuff in there, so you'll see more and more as there's automation pieces, embedded APIs, various system administration tasks that need to be done. They are more and more often being done in Python. The reason you see things like Perl scroll by is that the previous preferred language for doing various administration tasks under Linux and Unix has been Perl for many years. Perl was a extremely expressive, could get anything done, was there early scripting language that gave a little bit more sanity and capability than the previously frequently used bash script, or even more primitive Unix script. So it all kind of evolved out of the fact that when you have a command line, such as you do here, it only makes sense to support the execution of commands one at a time from out of a file. So when you have file.sh in the DOS world or in the Windows world, you would recognize them as file name.bat, bat files. Well, the funny thing is the concept for these is batch files. So there's a little bit of, go Microsoft, they got such a good 3-letter extension because .batch, it's a batch file. That's what these things are. But on Unix or Linux systems, you usually see them as .sh files. .sh files did a lot of the work in Unix and Linux world for many years. Until Perl started replacing them. That's why Perl was such a popular language early in the days of the web. Now, here's an interesting thing. We add a repository to what the apt system, the Debian package repository, it's dbpkg system, has access to software file-wise, and this is a group of people who maintain all the Python versions, current and past. And did I miss something? Need a single. I just typed it twice because out of my copy buffer and my screen recording stuff was in front of it. So this is okay. Press enter to continue. Okay, so I press enter. I have read about this before, so I won't bore you with a full reading of it here, but it's simply adding things that the apt update has access to. So you can see it's actually automatically running apt update. That's what, if this looks familiar, it should, because that's apt update happening right there. Now it has a much broader selection of software to choose from, including Python 3.10. So here is, and I know the next command will just be -venv, so maybe I'll type that when we get up to that. I breezed over that screen. Maybe I'll exit out of these screens. Well, that saved me a little bit of memory performance. Sudo apt install Python 3.10. Boom. Yes. And so you see, this is why, so many systems nowadays, it's too much of a generalization, why actions like asking for a fresh Ubuntu instance from the Lxd Ubuntu image repository gives you such a minimalistic system. It's really very plastic for you to mold it and shape it into what you want. It doesn't even come with a pre-installed Git or a pre-installed Python. So I installed Git and I installed Python. So now clear, I'll make that cursor nice and big. Python. Oh, Python not found. Exit. Go back into it. Python. Python not found still. Python 3.10. There, yeah. So we had to refer to it directly. I might install an alias or whatever to make it the same. That's a nice new version. And one more thing we want to do at this point is that last command with a -venv. Oh yeah, it's pip install. Okay, so if I do an ls in my home directory, you'll see we have the GitHub folder, and that's one of the 3 folders I very traditionally have. GitHub, where all my Git repos I put. Another very traditional folder I have here is the Python virtual environment I'm working out of, which we create with this command, Python 3.10. We know that's going to work. And we tell it to use the virtualenv that's associated with that executable to create a directory called py310. Oh, there I have with that strange redraw thing again. Forget what I did to get rid of that. Last swallow of coffee. So file I/O is clearly slowing down. I'm going to chalk a lot of this up to the screen capture, with this being up to 43 minutes already. It's funny, live streaming is probably less stressful on the system. Compresses it, gets it out of here, and it's not accumulating for ever larger local resources, or at least I think. I don't really know if there's a large local cache for streaming to YouTube and such. It'd be nice to have a little bit of feedback. Oh, there we go. ls. There we have it, the 2 directories. And by the way, one of these tricks that I do, I'll show it to you right now. Once you have a directory like that, I find it nice to lock yourself fully into it. So we could activate it now by doing source py310/bin/activate. And there you have it. See, there's our py310 now as our virtual env. You can deactivate, and you're now out of the virtual env, the way it modifies the prompt to show you that. And that is very useful, but it's even more useful when it's in your bash profile, which doesn't exist yet, so it has no entry. And here I will put the path out. I know it's always relative to home, so. And so now we can exit out entirely. And when we go back in, hey. What in the world? That was unexpected. I'm just going to close out of this, open a new one. This will be interesting. This is another first for me, logging into a session of a container where the console locked up on me when previously in it. These things have not had a single flaw. Everything from the time delay to that glitch here are new discoveries I'm making here with you. And I am really suspecting it's because my system is creeping to a crawl here with this recording. So I am going to pause it. Okay, I pretty much quit out of everything except for what we needed for this video. And we go back into the container. Oh, container. Yeah, that's wrong. Wrong container. I have a shortcut. Oh, there we are again. Okay, that's the clear command that's doing that, is it? Whew. Lxc exec q -- switch user login Ubuntu. Bam, we're there. See that? We're in as under that new container we just created. Now we should have Python 3.10 available, and we should be able to cd into GitHub here. We have a GitHub here as well. We should be able to cd into Pulse, and we should be able to vim pulse.py. Oh, assure ourselves we have a hello world program. Write and quit, not that we need to. And now we should be able to Python 3.10 pulse.py. Hello world. See that? Now let's create a pulse. The simplest way to do a pulse in Python. While true, I suppose, and then some sort of sleep until a certain amount. And yeah, let's test that. Vim pulse.py. While true, and from time import sleep. Sleep 5, that'll just be 5 seconds. Break. And each time it breaks, oh, as soon as it breaks, the program exits, so we don't really ever want it to break. So yeah, we just create a sleep loop in there, and then we, print hello again. That should just go into a nice loop and print hello again every 5 seconds until it's interrupted. Right quit, and then Python run it again, hello world. We see if in 5 seconds whether or not we have hello again. There it is. So this is a pulse. Now all we have to do is append out to a file, and we can look at that file and see stuff. So let's output something more like a timestamp. Control C, so we can Control C out of that. In our buffer, we have a command to edit it again, and we have time already. What else goes along with its date? From datetime, import datetime. And I think it's got a .now in there or something. Datetime.now, I think. And this is where IntelliSense people go, aha! Yeah, but I'm doing this directly on the container. You know, I don't have to have an IntelliSense program. If I really needed to, I could run over to another terminal. Okay, I'll open another terminal. Like, really, so what? I'm running the same exact version of Python everywhere. So I know I can just Python 3.10 here, and I can say from datetime import datetime datetime dot now. And I was right. There it is. And that'll be a nice easy string conversion. So I will actually put that inside what's called an F string. And that's just a really quick and easy way to force it to convert itself to a string in the way that's most intended to be read. I don't know. Ooh, somewhere along there it stopped recording. I am not sure if it did that or whether I did it by accident. But I believe we got up to the point where I was showing you how I created this lovely little heartbeat. You can Control C out of that, jump back into the Python program through Vim to show you once again what that program looks like. It's not very much, but now we will use a with open and a file name somewhere. And on every Linux system, this is one of those extra bonuses we're going to have thrown in. There is a place called /tmp. So we are going to open a file in a location where we know we won't have any real write commands, and we know how to get to it because it's a Unix/Linux convention, and it's in RAM, so it goes away every time the thing loses power. So we'll just call this pulse.txt, a text file as a log file. So we are opening that as a file handle, fh, colon, because that's under a with. This is the context manager. And then we have to make sure, once again, that we're using the correct API to append a line in with open. So I'll look at that in Google. That's fine. Should be fine. And I slowed down to a, yeah, it's pretty slowed down. On just an hour video. I'm so disappointed. Okay, so let's see. Context manager append. Should be super easy. How could the word append not appear on this page? With open right. Real Python. See, I got to be careful because a lot of these will like demonetize me. Append. Yeah, I just should trust my instincts, or say what would be. And look, they're manually doing a \n for a line return. So each time you do that, it will append, but it's going to be quite a literal append. So the Python code I am making, where was that? Yeah, okay. Yeah, put that in the wrong spot. With open comma append. Doesn't matter double or double quotes or single tick marks. Okay, so yeah, fh dot write. There might be other things here as far as methods like write line or something that would put in the trailing slash, and they're just doing it in a string that they're just constructing right there. So now we're going to do a now equals, and we'll put this here. And there we can use a now, and there we can use a now. And this looks like a time for an f string again. Because we need that backslash. Oh, you can't use backslashes inside of f strings. So it's already a string, so you can just append them together. And that'll do it. And I should be able to head or tail this service. Now, the funny thing is, this is in location as a service right now. So we're almost an hour into the video, but perhaps we can have the nice rewards of being able to I'm going to, well, keep cd'd in there. I'm going to use the old service command that I know, because I know it better than systemctl. So I can do service.status all. And as a newly created container, there's not going to be very many services running. But one of the services that we should be able to start, service service enable. Well, we might need to use systemctl after all. Systemctl. Look at that. See, it knew that I wanted to do it to that. I just hit tab and it autocomplete looked in the right spot. That was a little piece of magic there. Enable. Unknown operation pulse.py. That's fine. That's just a path being wrong. So all I have to do is, well, this is a different location on the same thing. So we do cd etc systemd service. In fact, we don't, since we know the path, we can just vim and we look at where we are now, ~/ so we'll expand that to, because I know that's /home/ubuntu/pulse, and then this file is pulse.py. I almost without a doubt just have the path wrong. So we're going to have to sudo vim edc systemd system pulse.service. There we go. So this looks correct. Ubuntu GitHub Pulse home Ubuntu Pi 310 bin Python 3.10. /home/ubuntu/github/pulse/pulse.py. That actually sounds correct. Now, one way we can test this is we can just copy that line, save and exit, try running it like that. There, see, no such, user bin screen. The screen is not on this. They don't pre-install the screen program. That's very interesting. But now it has me a little bit concerned, because one of the first things I really want to do here, first thing, I'm an hour into the video, it's the first thing I want to do, is make sure that that program still runs. So that's Python 3.10 pulse.py. Hello world. We'll let 2 timestamps go in. I'll control C it, and then I'll cd/tmp. I'll ls in there, and then I'll vim pulse.txt, which is the file we created, and there's our 2 timestamps. See, that's our pulse, that's our heartbeat. So I know that by running this program, that will be written out so I could tail that file. And it just will show you the last characters from the file. So even if that gets a lot of pulse entries, we can always look at the tail and see if it's changed since the last time. And that's how you know the service is still running. It is not still running because I controlled C out of it. But now we're in a really good point to get it running as a service. So how dedicated am I to having it so that we can log in as a screen? You know what? I'm going to change that that service to not use screen. It's just going to run this command directly, and I'll be able to get this back if I ever wanted to. But it's just going to run that Python executable space that file name as the service, and we won't have the screen login, and I'll make that another video, which is perfectly fine. So once again, I can test it by using that friggin' long path name that's in here. We take out everything having to do with screen, and there you go. Hello world. We'll let it write out 2 timestamps, and we'll look at temp again, and then we should have 4 total timestamps, because it should just keep appending to it because it's opening it as append. There's your 4 lines, right? So the heartbeat is continuing, right? This is showing you what we have in mind, and there's no harm in writing this file forever because it's in the temp directory, and the next time the system loses power or you stop and start the container, these contents go away. It's always a good idea to write to the temp directory if it's unimportant output and you don't want to clutter stuff. And so it's a perfect starting point for a heartbeat project. And hey, I get to tell you about /tmp, right? So anyway, we need to start that service now. Again, I'll use my old school way to just type service and then service status all. And you can see Pulse isn't there yet because we have to enable it. For that, we go to systemctl, enable, oh, interesting. Systemctl. Oh, it has this interactive interface now to it. Really, that's so interesting. I'm going to look into that more later. Systemctl help. And it brings up the man page interface. I like that when things do that. Did I scroll right over it? There we are. Start, stop, reload. Right, so enable, name. Okay, I think it's easy enough. Systemctl enable pulse.py, pulse. The name org.free desktop policy kit 1 was on. Do I have that in my service? Oh, there we go. I just had to sudo it. And so now, system status all. Oh, service status all. Oh yeah, we just enabled it. It's because it was previously disabled, so now we have to start it. There's service, there's systemctl. Start, pulse, service. Okay, it completed it. Failed to start. Oh, let's try with sudo, of course. Keep hitting the same mistake. We're like an hour and 10 minutes into this, and it looks like I might just have my first service started on a container. It's taking a while to do it. There's probably some overhead on the first time something is run. Okay, I had to get up and come back to the problem. One of the things I did was check the file permission and set a very standard file permission for services. So I can do an ls-la to show the different services and their file permissions here. The one I have just created on my own is this pulse.service, and we can see, oh, see, everything else is a link or a directory in this location. Is there any other .service? The only other .service is a link. But at any rate, oh, it doesn't even have the executable bit. I'm amazed it's working. So let's sudo chmod +x to service. Now it's actually already working, so this is a little gratuitous here. But if I do another ls-la, you will see now that the pulse service has that little X there. Now, what I was failing to do was work with both sudo and working 100% under the systemctl command. I was using the service command, which was from the long ago from other experiences I've had. So as long as I settle in on systemctl, I can, first of all, do -a to list everything, and I can scroll down using J and up using K. See, all those keyboard shortcuts you learn for Vim apply everywhere. And as I scroll down here, I can see here Pulse is actually loaded and active and running. And I can quit out of here and then do systemctl stop pulse. Oh, I got to put a sudo in front of it. Sudo. And now I pull up that systemctl all again. Scroll down to where pulse is, and you can see it's loaded and inactive. They put the word dead in there, but I can turn it on and off now in that way. So if I have been turning it off and if it has been working, then I should be able to, well, first of all, let me turn it on again. Start. It should not complain. See, it doesn't complain. I was having problems with this step before, if I ever even really typed it in exactly that way before. But if we go to cd/tmp, oh, one thing before I leave here, sudo vim pulse.service, I had the type to forking before. Now I had that because I was going through screen, and screen was forking its own task for console and whatever. But now it's in simple mode, the most popular mode for this sort of stuff. And this is running as a very simple script. This is the interpreter, such as it were, and this is the file being fed to the interpreter. And so I had done that change, just went from mode forking or type forking to type simple. And you saw me change the file permission there, although that seemed to have not stopped it from running. And we can go to cd/tmp ls clear vim pulse. I can go in with vim, and you can see here when the file was first made at the 21 hour, and here when I came back to it at, I guess, the midnight hour. This is using GMT time, Unix time, I believe, from not having set any local. And yeah, so it was running a while. When I got up to do other stuff and to come back to this later, I had clearly left the service running, and there's my heartbeat, there's my pulse, going there for quite a while. And I could tail it, and that would be a way just to check it intermittently to see that that last number changed. See, even between the time I just ran it and the time I ran it now, there was one more entry put at the bottom of the file. 44. Yeah, this file is going to fill. It's writing into temp, but this is now fairly good reason to change the the service a little bit. It's filling this up quite a bit. So there's never any harm in remove pulse.text, because the append command will recreate it. Probably by the time I run tail again. See, there it is again with one line entry in it. There's your pulse. We've got a pulse. cd //github pulse vimpulse.py, and this is every 5 seconds. Let's turn that into, every let's see, 60 seconds is a minute. 60 times 6300 is an hour. 300 times 12. Well, let me just bring up the calculator. So 60 minutes in an hour. If we want to do a pulse every, let's see, 4 hours. That's not 60 seconds. So that's not right. 60 seconds in a minute times 60 minutes in an hour times 4 hours. Yeah, 1440 is what I want in here. And now, since we changed it on the drive, there is another step that would be good to do, good habits to form, and that is systemctl restart pulse. Oh, I've got to do the sudo. And there, if it was in memory before, this dumped it from memory and brought it back in, and so it has the new contents. And there we've written a basic service. There will be other parts to this video, follow-ons. I'll probably do this one again to clean it up into a nice smooth process. But yeah, we'll put the screen terminal thing back into the picture and do things, pulse actions other than just writing out to a temp file. Again, cd/tmp vimpulse.txt, and it started out with every 5 seconds, and then it switched over. This will probably not have another entry in a good long while, so I can, what can I do? Should I leave it like this? It's not that confusing. It's a little confusing. Remove pulse.txt, and I'll restart the service. And then I will vimpulse.p. See, it's not even existing yet. It will only get created probably after that amount of time elapses, depending on how I wrote that while statement. cd/etc, just as a reminder, etc/systemd/system, and in here you've got a list of services. Clearly the practice is to symbolic link things in here, and there's also these directories that are going on here. So by just dropping a file in there, it's probably not the most kosher way to do it, but it gets the job done. Oh yeah, this doesn't show how I wrote it. This shows how I activate it, how I make sure it gets run. So to see how I wrote it, that's cd//github pulse vimpulse. This is how I wrote it. Yeah, so it's going to sleep that many seconds before it even does the first write. So that pulse is, well, true, sleep. Yeah, I should probably put that at the end here. Restart the service. And now we can vim /tmp/pulse.txt. The fact command line completion worked showed it, so there it is. It's a good pulse demo. And I'll stop there. That does it for today.